الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello everyone. I'm so happy to be with you for the session today. First, my name is Eman, and today we will talking about an important topic about Arabic text clustering. Before we going to start, I did many sessions related to Arabic NLP before. If you wanted to watch it, you can see it about different projects for the Arabic NLP, and we can start now. This overview for today, just we will talking about what is text clustering and the application for it, the difference between text clustering and the classification, and what are the types of clustering with the pipeline, and how to extract textual features for clustering. Also, what is the level for text clustering, and the common algorithm that have been used, and the measure for the performance for each metric, and the change for this topic. The amount of text data being generated in the recent years, I think, has exploded exponentially. And also, it's essential for organizations to have structure in place to mine important sites from the text being generated, like from the social media analytics to risk management, or cybercrime protection. Dealing with textual data has been more important. Also, the text clustering is the task of something we say grouping a set of unlabeled text in such a way that text in the same cluster are more similar to each other than to those in other clusters. And also, text clustering algorithm process text and determine if natural cluster, or meaning the group, exists in the data. Here is the big idea: is that the document can be represented uh, numerically as vectors of features, and the similarity in text can be compared by measuring the distance between these feature vectors. Also, objects that are near each other should belong to the same cluster. Objects that are far from each other should belong to different clusters, and essentially we have involved for three aspects. First, selecting a suitable distance measure to identify of the two feature vectors. The correlation function that tells us that we have got the best possible clusters and stop further processing. And the last one about an algorithm to optimize the accreditation function, and the greedy algorithm will start with some initial clustering and refine the clusters iteratively. So the main idea for the clustering just to group the similar items together for the unlabeled data. Unlabeled data means that we didn't have y, just or what we have is the input and we don't have any output referred to it. There are many applications for text clustering. One of them, document retrieval, just to improve recall, start by adding other document from the same cluster. For example, we have another application that fake news identification. We can detect if the news is fake or not. Also, language translation, the translation of a sentence from one language to another. Also, maybe the application of spam mail filtering to detect is spam or not. Um, we can say that customer support issue analysis just identify commonly reported support issues. Here is what is the difference, or how is text clustering different from text classification. Classification is a supervised learning approach that maps an input to an output based on example input output pairs. Okay, but the difference here that clustering is an supervised learning approach. Actually, here is you can see from this image clustering. All of them is like a blue circle, but here is for the clustering. But for the classification, you have only labeled it. You have red circle. You have green stars, and like this. The classification, if the prediction value tends to be categorical or like yes or no, positive, negative. Here is you can from this picture is multi-classification like maybe red, blue, and green and something like this. Then it falls under classification type problem in machine learning. The different crosses are known in advance. For example, if you have given a sentence and predict whether it is negative or positive review, and we call this project is a sentiment analysis. Sentiment analysis is basically for classify a review of book or review of product or review for anything. Just if it's positive or negative, when a customer say maybe I love this product so much, so the model can predict it as positive. And one say when he watched a movie or something like this, I don't like this movie, and my model can predict it as a negative. This is for classification. What about the clustering? The clustering is a task of partitioning the dataset into groups called cluster. The goal is to split up the data in such a way that points within single cluster are very similar and the points in different clusters are different. Just we need each group to be similar together or maybe have the same characteristics and for the different clusters are different. It determines a grouping among unlabeled data. What are the types of clustering? Clustering can be divided into two groups. First is hard clustering. Hard clustering this groups the items such that each item is assigned to only one cluster. Maybe, for example, we wanted to know if a tweet is expressing a positive or a negative sentiment, and we can say key means is a hard clustering algorithm. The second type is soft clustering. Sometimes we don't need a binary answer. Just soft clustering is about grouping items such that an item can be belong to multiple clusters. We have, for example, I think fuzzy C means is one of the most common soft clustering algorithm. Just the difference between hard and soft is hard is about to assign to only one cluster, but soft is just for grouping items for to belong to multiple clusters. Here is pipelines for text clustering, especially. Just we start, we have the data, and then we do the feature selection and extraction. After that, we apply the clustering algorithm. After that, the validation, and just to get the result and evaluation and test it. Okay, but there are the approach involves the three main steps. First step is about text pre-processing. As you know that text can be noisy, hiding information between stop words, maybe and sparse presentation or something like this. Pre-processing makes the dataset easier to work with. Okay, and about the feature extraction is one of the commonly used technique to extract the features from the text data is calculating the frequency of the words by tokens in the document per characters. And the last one and the most core one for our project is the clustering. We can then cluster different text documents based on the features we have generated. For this step, for the text pre-processing, we do many things like tokenization, lemmatization, removing stop words, and something like this. And this is important. This stage is important because, as I mentioned previously, sorry, that text can be noisy and they can hiding information between stop words, so maybe you need to remove it or do something better that can make my model to understand the sentence or the input well. Here are the main components involved in pre-processing. First thing is about tokenization, and the tokenization is just the process of parsing text data into small units, such as words and the phrases. And after that, the normalization, I just wanted to convert the text to lowercase. Why that? Because I want to make the car with capital like the car with a small. I don't want to make the model to understand is these two different words and something like this. And you can imagine if you apply it for the whole sentence, and actually when just because we apply it for the Arabic, something like for the Arabic we don't have something like for that, like Ali and Sayora and so on, because we don't have this especially for the English language. But for this step, for the tokenization, we can just remove diacritics and something diacriticization for the Arabic language in the text, and maybe remove the bourses HTML tags and something like this. About lemmatization and stemming, um, mainly the step of normalization, we don't need to do it for Arabic language, but maybe we need to do it for English for sure. But for Arabic language, we have to do tokenization and lemmatization with stemming, and last one, removing the stop words. What is lemmatization? Lemmatization is like that's a process for removing or transform a text into root form. And this for the stemming and the lemmatization techniques are used just for driving the root word. And for sure, all of these steps just to decrease the amount of information and remove anything useless. Last one about the stop words. Just stop words are common words that used like في من على in Arabic, and also you can give an example in English like and is the and something like this. And these words don't carry important meaning for text clustering and are usually removed from the text. These words have high frequency with less meaningful. How to apply these steps for that, how to do the tokenization in Arabic. In this process, like the Arabic document is split into words according to the punctuation characters and other samples. The text will be as a stream of individual documents like this. We will convert this sentence in Arabic to be one word per line, and for each word we will get it a number. It's called token. And you can calculate the time complexity for this step is O of k, which or where k is the number of the vocabulary in the collection. The second step after that is about the stop word removal. For stop word removal, after cutting the text into tokens, the next phases is the stop word removal. Arabic stop words include any word that is not considered part of speech, like من مهما في إلى أيان ما سوى and so on. And you can see and you can check it by yourself. But here's for the Arabic language, we can apply it, and applying stop words removal on the tokenized text. And I think the time complexity for this step we is a linear, just to multiply O of t multiplied by k, which t is the number of stop words, and the key, as you know, that previously in the previous session, in the previous slide, that is the number of the words in all the documents in the collection. And from this slide, you can see here's we remove from this example هذا and في. This removed because these words don't give any meaning. We can just remove it, and we can save or keep the same structure with the same meaning, and can make the model understand it and reduce the complexity as much as possible. The step after that, and this is the last pre-processing phase, is converting the words into their roots. In Arabic stemming, almost all nouns, verbs, and adjectives are derived from a few thousand roots. And this, you can see from this, we have two types of the stemming, heavy and light stemming. And for heavy stemming, returns words into their root, but for the light stemming, returns words into their roots by removing all prefix and suffix of the words. Here is you can see here is you can see the example for this, the country Al-Iraq, and here is for the heavy stemming. For to give its root is Irq, but for the light stemming just is العراق. I remove the prefix, and here is the prefix, anything that at the beginning of the word, but it doesn't belong to the word itself. Like al is a prefix. Okay, and the second example the same, no different between the heavy and the light. And maybe بمبادرة, and hers for the heavy stemming is بدرة, but for the light stemming it just remove the prefix, the letter باء, the preposition حرف الباء. Here is the second example لتأسيس, and here is just I remove letter لام, حرف اللام. But for the heavy stemming just I get its root is SS. I wanted to move to the last example about إسهاما. إسهاما, and here you can see سهم, but here is for the light stemming I removing the suffix. The suffix at the end of the word, but it doesn't belong to the word, the original word. So I remove it for the light stemming. Again, for the light stemming, just I remove the prefix and suffix. But for the heavy, just I give it for its root. After we have finished the stage or the step of data preprocessing, and for the data preprocessing has three main components about the tokenization, stopword removal, and stemming. This is for Arabic language, but for English, just we add something is called the normalization, just to make everything in a small letter. Okay. After that, my data is ready just to represent it to get into my model. And for sure, there are many types of data representation for text document. And one of the most used representation is called vector space model. And just for a recap or in a brief about the vector space model is each document and the query is represented by a feature vector. Okay, just the importance of each term in the document is found by calculating the weight of each term. And for sure, larger weight means that the specific terms are used frequently in relevant documents, but rarely in the whole document collection, therefore. And for this model, another factor is used to reflect the relevant, which is inverse document frequency, IDF. Okay, and the IDF if the terms occur in few documents are helpful to discriminate the document from the rest of the collection. How do I define or extract the text feature for cluster? In general, words can be used to represent a common class feature, and word characteristics are also features. Okay, for example, capitalization matters. This only for the English. Maybe the characterization or something like this. Maybe part of speech and the grammatical structure also added to the text feature. Semantic can be used. Uh, and the mapping from text data to real valued vectors is called a feature extraction. Okay, and one of the simplest techniques to numerically represent it, like the bag of words or something like this, and we make a list of unique words in the text corpus called vocabulary. This is for English, and also there are another for Arabic. Okay, then we can represent each sentence or document as a vector, with each word represented as one, just a presence, or absence as zero. And we can make another representation is to count the number of times each words appear in a document. And the most popular approach is about the TF-IDF technique. But the most recently about the word embedding are being used to map words into feature vectors. Just word to vec is a popular model for word embedding. What are the levels of text clustering? Text clustering can be document, sentence, or word level. For example, for the document level, serves to regroup documents about the same topic. Document clustering has applications, so many applications for sure, like in the new article like Wikipedia, email, search engine, and so on. For the level of the sentence, it's used to cluster sentence derived from different documents. And we can say an example for it like that tweet analysis. And the last one for the word, just the word clusters are groups of word based on a common theme. And the easiest way to build a cluster is by collecting a synonym for a particular word. And for example, WordNet is a lexical database just for English, and there are the similar for the Arabic. Just its groups word English word into a set of synonym called synsets. Which are some common text clustering algorithms? Maybe by ignoring the neural network models, we can identify different types. One of them is hierarchical. In the diverse or divisive approach, just we start with one cluster and split that into subclusters. Just an example algorithm, we have something is called MENA or MONE. In this approach, each document starts as its own. Maybe you can see here, as you see from the picture. Just each document starts as its own cluster, and then we merge similar ones into bigger cluster, like this. Another one is called the partitioning. Key means is a popular algorithm but requires the right choice of key. Another type another algorithm is called dynasty. And instead of using a distance measure, we form clusters based on how many data points fall within a given radius. We have another algorithm for is called for graph or was called graph, and there are many algorithm known in this umbrella under this umbrella. Sorry, some algorithm have for the graph. Some algorithm have made use of knowledge graphs to assess the document similarity, and this address the problem or the ambiguity and the synonym similar meaning. Last one about probabilistic. A cluster of words belong to a topic, and the task is to identify these topics. Words also have probabilities that they belong to a topic, and the topic modeling is a separate NLP task, but it's similar to soft clustering. It's important to know the difference between the key means and the hierarchical clustering. For example, for the key mean is very efficient to use, and the hierarchical clustering can sometimes be slow, especially for large dataset. Um, Here is for the key means that you want to add the number of clusters, but for hierarchical sorry just you don't have to do it, are not required. um, Always for the key means more likely to return a different orientation of clusters, but in another type or in the another side just always returns the same clusters. And another different that you should to be considered for the key means always return the same partitioning for data for fixed number of clusters. But here for the hierarchical clustering, it can return more than I partition, one partition, and all for sure is based on the resolution. How can I evaluate the efficiency of a text clustering algorithm? Measuring the quality of a clustering algorithm has shown to be as important as the algorithm itself. We can evaluate it in two ways. One of the way is called external quality measure. External quality measure is external knowledge, or external knowledge for sure is required for measuring the external quality. Okay, for example, we can say that we can conduct a service of users of the application that includes text clustering. For the another way is called internal quality measures. The evaluation of the clustering is compared only with the result itself. That is another, and the two main concepts are separation or that you need to know is called compactance and the separation. For the compactance, it measures how closely data points are grouped in a cluster, and for separations, measure how different the found clusters are from each other. And for compactance, is the intra-cluster variance, but for the separation is inter-cluster distance. Is the most that you should to know. Also, that you need to measure the similarity in text clustering itself, and words can be similar in lexical or semantical. So, for here's lexical similarity, words are similar lexically if they have a similar character sequence, and the lexical similarity can be measured using a string-based algorithm that operate on string sequence and character composition. For the semantic similarity, words are similar semantic if they have the same meaning or opposite of each other, used in the same way, used in maybe in the same context, or one is the type of another. And the semantic similarity just can be measured using a corpus based or knowledge based algorithm. And some of the metrics for computing similarity between two pieces of text, like we say, are cosine similarity is the most popular one, or Euclidean distance, and something like, and maybe Jaccard coefficient. Last thing about the challenges, or maybe for the text clustering in general. There, what are the common challenges involved in the text clustering? For sure, the document clustering is being studied for many decades. It's far from or solved problem. The challenge, we can say, for example, selecting suitable features for documents that should be used for clustering. Another may be selecting the suitable clustering method for and with the similarity measure, implementing the clustering algorithm in efficient way that makes it easy in terms of the memory and the GPU, for example. Maybe finding ways of assessing the quality of the performance clustering, and so on. And for sure, any tasks we faced some challenges, some in progress, and some done, and some just in between. This for all the session today. I think we can answer the question now. Yusra asked that do we need lexicon to label review as example that is an unlabeled? No, just the clustering techniques is just to group some similar. Just we add that something is a noisy, and after that we do the distance and measure the distance, and we represent the words in a vector. So each word is that represented in a vector space and something like this similar, we can group it together, and so on. And we do these steps about the displacement and measuring the distance. until we reach to the satisfied result. We can wait for 2 minutes if anyone have any question. Okay, I think no question. Just last thing about these resources, if you wanted to go in depth for this topic about the text clustering, and here is the two papers about the Arabic text clustering, and you can go in depth for it and how to. Yes, okay. Just if you wanted to go in depth for this topic. And for sure, if you have any question anytime, you can ask me, and I hope to answer you, inshallah. Thank you for joining the session today, and inshallah, see you in another session. Assalamu alaikum.